Hi guys and girls, today we're looking at applications of exponential equations, okay? And what I've done to the right in the red box is just put up a general form of the exponential equation, okay? And this shows me that K, B, C, A, D are all variables. They're all things that I can change, okay? And still have an exponential equation. So what I'm essentially going to do is read through each application question and then work out what goes where. Okay, just some general things before we get started. Most of these equations work that K is your initial condition. Okay, it's a fancy maths way of saying K is the starting number. Okay, so K is generally where it starts. Okay, A is the term for how much it changes with each step. So each step it might triple, it might be times by 5, it might be times by 1.5, it might be times by 1.7, but A is how much it changes each turn. Okay, D is if I want to add something to the sequence, and B and C help me change the period of my turns. Okay, so like each year, each whatever period of time it does something, B and C help me alter that period of time. Okay, hopefully that'll become clear in doing the question. Okay, so let's get started. Okay, reading this question, it states that prior to a mice plague which lasts 6 months, the population of mice in a country is estimated to be 10,000. The mice population doubles every month during plague. If P represents the mice population and T represents the number of times from the plague to start, express P as a function of T. What that means is write an equation where you put in T and it gives you P. Okay, so to do that, 1A, I'm just going to start off with P equals, okay, and now I need a number for K. I need a starting position. Okay, and here it starts with 10,000. 10,000 is my initial condition. 10,000 is what I have at the start before it starts changing. Okay, so I write 10,000 in that starting position. Okay, then it goes that the mice population doubles every month of the plague, and that doubles is my A. It's how it changes every month. So I'm going to take that 10,000 and I'm going to times it by 2. Okay, because timesing by 2 is an expression of doubling. Okay, it doubles every month, so I'm going to put times by 2. Okay, now I need to see the exponent part. Okay, so I've got B plus bx plus c, but it just says every month. Okay, and it's doubling every month, so I'm just going to put to the power of t, and I'm not going to change it. Okay, but notice the question said put it as a function of t months, so I'm using the variable t months. Okay, now we can get on to part B. Part B I says how much is it after 3 months? So I go P equals 10,000. I'm just copying my answer from above times 2, copied from above, to the power of t. Now here t is 3 months, so I'm just going to put 3. Okay, and 2 to the power of 3 is 248 times 10,000, 80,000. Okay, double I 6. So I do exactly the same thing, P equals 10,000, just copying my equation, times 2 to the power of 6, which equals, or 2 to the power of 6 is 2, 4, 8, 16, 32, 64. The 6 months, it'll be 64,000. Sorry, it'll be 640,000. I thought 64,000 seemed a bit light. 640,000. Forgot a decimal place. Okay, so that's B, I, and double I done. Okay, now calculate how long it's going to take the population to reach 100,000 mice during the plague. Okay. Here, what I do is C, P equals 100, or sorry, here I'm given something different, so I can't use the same equation in the same way. What I'm going to have to do is calculate how long it takes to make 100,000. So what I'm going to do is chuck 100,000 down the bottom. And I'm going to put that in the position of P. Because I want to work out, I know what P is, my 100,000. I want to work out T. So I chuck P into my formula, and that's going to equal 10,000 times 2 to the T. I want to find out what T is. So the first thing I do is just divide both sides by 10,000. And I got 10 equals 2 to the power of T. Okay, and I'm just gonna do this by counting. Okay, so 2 to the power of 2 of 1 is 2, 2 is 4, 3 is 8, and 4 is 16, more than 10. So it's going to be it's going to take 4 months. Now in the back of the book, they might give you a decimal, which they use logs to find out. But for us this year, with the new version of the curriculum, we shouldn't be using logs yet. Okay, so this answer is perfectly fine. 4, and I've got to put down months. Okay, how long does it take to reach 10,000? 4 months. Slightly less than, but for us, because we're not using logs, 4 months. Okay, hopefully that took you through the entire thing. What I'm going to do now is question 4. Okay, before I get started on that, I'd just like you to pause the video and have a go at question 4 yourself. Okay, now just a few hints. I'll read through it and give you a few places to start. If $8 is the amount invested, investment of P grows to after n years at 5% per annum, write a function with write A as a function of P. Okay, you've got to replace that stuff there. Notice that A as a function of P means what you've got to do is have P dollars on one side, A dollars on one side, and then P and N on the other to equal A. Okay, so give it a go. And then have a go at B and C as well. And I'll do an example, okay? If you want to just skip to the end and see if you're right, and if you are right, move on. That's awesome too, okay? But do give it a go and engage with it yourself, because then my sort of go will make a lot more sense. Okay, so I'm assuming that you've had a try. The first thing I'm going to do is just rewrite that formula from the top, just to give myself the tools that I can put numbers into. So it's y equals k a b x plus c plus d. Okay, So if A is the amount of an investment, P grows after n years. Okay, so A is the amount of the investment. It's the first thing. It goes out the front because A as a function of P. So when P changes, it needs to influence that number in the front A. That's what write A as a function of P means. A on one side and all the rest on one side changing with P. Okay, now P is the amount invested, so it's my initial amount. It goes there. Then it grows at 5%. Okay, so that's times by, and this is the step. Okay, this is the A part. Okay, it's going to be 1.05. Notice 1.05 is the whole 1 and 5%. Okay, and all of that goes in to make my A. The whole 1, because you don't lose money on the investment, and an extra 5%. Okay, and that's to the power of n. Okay, because my power is how many times I want to times it by itself, and I want it to times it by itself for n years. Okay, so that's the first part. That's little a. That's part A of question 4 done. Okay, let's have a crack at part B. Part B, write the function from A to find the value of $10,000 after 10 years. Okay, so I'm just rewriting it. A, because that's the value I'm trying to find. $10,000 is what's invested. So that goes there for P. Okay, and then 10 years is the N. So it's 1.05 to the power of 10, because N years, 10 years. Okay, so now I'll just find my answer using my calculator. So I had 1.05, okay, to the power of 10, which equals, okay, and then this is what I'm going to times my principal by. Okay, this is 1.05, or the 5% for 10 years, and then that number times 10,000 equals 16,288.95, because I'm going to round it to 2 decimal places because it's money. So 16,288.95. Okay, and that's part B done. Now for part C. Calculate how many years it will be until the investment reaches, investment of 10,000 reaches 26500. Okay. This one, the book uses logarithms, but we're not, because that's not part of our curriculum. Okay, but I'll show you how to do it without logarithms, and you won't get the decimal accuracy, but it will be right. Okay, so 26,500 is what it needs to equal. So C, my A is going to be 26,500. Okay, then that equals 10,000 times 1.05 to the power of n, the number of years. And n is what I'm trying to find. So my first step is just to divide by 10,000, and I get 26.5. Okay, when I divide both sides by 10,000, that cancels, and I'm left with 26.05. Sorry, 26.5 equals 1.05 to the n. Okay. Actually, this is going to take a lot to do without logs. Okay, but we'll give it a go. Okay. So I've got 1.05. Okay, and what it's asking is how many times do I need to times it by itself to make 26.5. Okay, so I go times 1.05 equals, okay, times 1.05 equals. So now that's 3 times. If I press equals again, give me 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times, 12 times, 13 times, 14 times, 15 times, 16 times. Just waiting for the first time it gets above 26, 17, 18, 19, 20. Okay, so it's 20 times or 20 years because now it's at 26.05. Oh, sorry. Yes, sorry. It is 20 years and equals 20 years. As you can see, I made a mistake and wrote down 26.5 instead of 2.65, which is the answer. Okay, sorry for that. 10,000 divided by 26,500 is 2.65. Okay, hopefully that wasn't too bad a mistake and that didn't confuse you, and that we can do all of these questions now. If you have any problems, queries, or doubtful points, just ask me. Okay, send me an email or ask me in class. Hopefully that was helpful. Bye guys and girls.